Okay, I'm going to begin doing some of the homework problems, some examples. And I will work at least, I'm going to try to do one or two from each section for you guys. I'm going to start with number one is fairly easy, but kind of thinking, I guess I could skip to just number two. But just to kind of review what we're doing. Number one, you can see that 8 goes into both 16 and 24. So 8 goes into 16 2 times. And 8 goes into 24 3 times. Using the exponent rules, you would subtract the exponent 2 from 7. So that's going to give you a -5. So that means you would have m to the 5th. And because it's negative, it'll be in the denominator using our good old exponent rules. Number two, you want to factor both the numerator and the denominator and see what you can eliminate. So on the top, you can take an n out. So that's going to be n. And n goes into n squared, gives you an n left over, and goes into 7n with just a 7. On the bottom, you can factor out a 4n, and then that's going to leave you an n plus 7, because 4n goes into 4n squared with an n left over, and 4n factors into 28n 7 times. So the n plus 7 both factor out, and the n on the top and the bottom factor out. That doesn't leave you with a 0 on the top, however. That leaves you with a factor of 1 left over. Very important to note that. So your final answer is 1/4. All right. I am on number 3. That would be factored. The two factors that multiply together that give you a -24, that when you add them give you a -10, are going to be x minus 12 and x plus 2. Because you know you have to have one positive and one negative to give you a negative to multiply together. So these two cancel each other out, and that leaves you with x minus 12 as your final answer. All right. This top one is the difference of two squares on number 4, because I note that this first term is a perfect square. 1 is a perfect square. Good thing to always remember. We kind of forget that 1 is a square, but it is. And then, or is a perfect square. It's a perfect cube also. And then 9w squared is a perfect square. So that factors 1 minus 3w, because that's the difference of two squares. So it factors to 1 minus 3w and 1 plus 3w. That's that special factoring pattern, the difference of two squares. And now this bottom, you can factor out a 4, and that's going to give you 3w minus 1. Okay. Just on like that worksheet yesterday that we had in class. Oops. I want to remind you right here that this equals a -1. So when you have A minus B over B minus A, that equals a -1. So that is this scenario right here. 3W minus 1, 1 minus 3W. That factors to be a -1. So so you take that out and that out, but it leaves a -1 on the top. You also have 1 plus 3W left over 4. And then when you distribute that -1 throughout the parentheses, that actually will give you, I need to make that a little smaller, a -1 minus 3W over 4. I'm going to leave you guys to 5 and 6. Just noting that the top, remember to factor out, simplify before, simplify the top and the bottom, but 5 and 6, I'll leave you to do. Now 7, I'm going to work on 7 and 8 with you. Or I'm trying to think of, I'm looking through to see if any of them have anything funky or tricky to them. I might try to do some of the odds. I don't see anything too unusual. Let's multiply through. 32 times 15 is 480. And then x cubed, there's no x's to multiply across. You would add the exponents if there were. There is a y in the numerator of each with an assumed 1 as an exponent. So that's going to be y to the second all over 40. And then you've got an x to the first to combine with the x squared. So that's going to give you an x cubed. And then y squared times a y to the fourth. Combine your exponents. That's going to give you a y to the sixth. And now you're going to reduce. And 40 will go into 480 12 times. And then you'll use your exponent rules. You've got x to the third over x to the third. 3 minus 3 is 0, so that's just x to the 0. And anything to the 0 power is always 1. So your x's kind of cancel each other out. And then you've got y squared over y to the 6 using your exponent rules. 2 minus 6 is a -4. So if the exponent is negative, it goes in the denominator. So that's going to be y to the fourth. So your final answer is 12 over y to the fourth. Oh, hey, guys.
Hey, Ms. Park.
How are you?
Good.
I had emails to go over a few of the examples that someone couldn't make Math Lab today. So I was just going to randomly go through some of them. But if you have particular questions, please, stop me or ask me if you're stuck on one for sure.
Actually, mine was just 7 through the end. So you were starting right where I needed to start.
Okay.
Me too.
All right. How about you, Anna?
Number 9 and 10 in particular.
Okay, number 9 and 10 in particular. Okay, great. All right, I will for sure do those. So I don't know when you joined in, but if you saw some of the ones at the top or not, but all right. So number 8, you obviously on that top one, we're going to factor first before we multiply across. So we've got what we're looking for in the numerator is what 2 factors of 8 will add together to give me a -6. So that's going to be m minus 4 and m minus 2, because a negative times a negative would give me the positive, and then 4m plus negative 4m plus a negative 2m is going to give me a -6m. And this down here on the denominator, I'm sorry, factors to give me m minus 1 equals, and then 10 times m minus 4. So you look for those things that can cancel, and the m diagonally or vertically. So in this case, the m minus 4 cancels, and then the 2 changes, goes into 10 5 times. So now we're left with 5 times m minus 2 over m minus 1. And you don't have to distribute that 5 to the m and the minus 2. You can leave your answer just like that. Okay, for number 9, we're going to factor that numerator on the left-hand side. We can definitely factor out a 4. So 4 goes into 28, 7, or 28n goes into, 4 goes into 28n, 7n times, 4 goes into 40, 10 times. Factoring the bottom, we can factor a 5 out, and that's going to give us 7n plus 10 on the bottom. Factoring the top out, we can get a 12 out of 12n plus 24. And that's going to give us 12 times n plus 2. We can factor an 8 out of the denominator, and that will give us n plus 2. So now, I'm sorry?
Are you trying to get like the same on like the top and bottom? Like
If you can, because obviously, you know, all that stuff that you can cancel out, the better, you know?
Yes. Okay.
Okay, and so you can cancel things out either diagonally or vertically. So now, vertically, the 7n plus 10 cancels with the 7n plus 10. Okay. And the n plus 2 cancels with the n plus 2. But I look and I see that I've got a 4 here, and that will cancel that 8 out to be 2, right?
Yes.
And now this 2 will cancel to be 1 with the 6, and that will leave me a 6 on the top. Does that make sense to you guys?
Yes.
So that I have almost everything canceled out on the top except for a 6, and everything on the bottom, we've got 5 times 1, which is 5. So beginning with all of that stuff up there, my final answer is actually that. Crazy, huh?
Yeah.
The other thing that you could do in this case, if you didn't really see all that vertical and horizontal stuff, just so you guys know, you could have multiplied the 4 times the 12, which would have given you 48, and the 5 times the 8, which would have given you 40, if you prefer doing it this way, and then seeing that 8 goes into both of those, which then reduces to 6 over 5. However, that would have been easier for you guys. You're welcome to do it. I just want to make sure I show you both ways. It really doesn't matter because obviously you see where you get the, the same answer. Does that make sense?
Yes.
Okay. All right. So number 10, there's really nothing to factor in that first rational expression. So we're going to take a look at the second, the p squared minus 5p minus 36 over 4p squared plus 16. I'll just go ahead and rewrite p plus 10 over 9 minus p. And I'm going to write this in its factored form. I'm looking for two factors that multiply together that give me a negative 36, that when I combine those factors, give me a negative 5. So I know that one has to be negative and one has to be positive, and the bigger of the two has to be negative. So I know that negative 9 times a positive 4 would give me a negative 36. So I've got p minus 9, p plus 4. And on the bottom, I can factor a 4p out of both 4p squared and 16p. And now I'm going to look for things that cancel. And I'm looking at this cancels. And then there's that special pattern that we keep talking about, the p minus 9 over 9 minus p. That's that negative 1 thing. Remember?
Mm-hmm.
So we've got this actually factors out and gives me a negative 1. So I've got a negative 1.
How do you know to put, like, if you put the negative 1 on the top or the bottom?
Great question. I would default always to the top, personally. But if you think about it, negative 1 is equal to this or this. But I would default to the top if I were you, because this is like a negative divided by a positive or a positive divided by a negative. But like I say, I would express it like this when using rational expressions.
Okay.
That would be my default. Does that make sense?
Yes.
Okay. So that cancels out and gives me a negative 1, because not sometimes you're going to, I guess my reasoning behind that, Anna, great question. My reasoning behind that is sometimes you're going to end with only something on the top.
Oh, okay. Yeah, that makes sense.
That way, if you default to that, it just is it's a little easier.
Okay.
And so then I have my p plus 10 on the top, and then I've got 4p left on the bottom. And like I said in class yesterday, and I don't know if Miss Wynn Garrett feels this way or not, I'm happy if you leave it like this. But if you wanted to go ahead and distribute that negative 1 all the way through the parentheses, your final answer would look like this. Either one for me is fine. Like I say, I told my students I'm kind of celebrating that you all are getting that negative 1 concept and what that looks like. Any questions so far?
I'm good.
You good?
Yes.
All right. Would you guys like me to at least do 11 and 13 in this section?
I
Yes.
really like to do everything, but I mean,
All right. Well, let me at least do 11, 13, and then get 15 and 17, get some of the odds done, and then we'll see what kind of time we have, and then I'll go back. Is that cool?
Yeah. Could you scroll back up to the last one you did, because I didn't finish copying it down.
Oh, yes, sir. Sure can. Is that good?
Okay, I got it now.
All right. Okay, so number 11, just pointing out some factoring patterns right away. This first rational expression, the v squared minus 49, what I want you guys to start recognizing is that is the difference of two squares. So that's going to factor very quickly and easily to v plus 7, v minus 7, all over 20v cubed. Can't really do much with that. It's just a monomial. So, and then this second rational expression, I can factor a 4v out of the top. And then on the bottom, I'm looking for two factors that multiply together that give me a negative 42, that when I combine those two factors, they add to be a positive 1. So let's see, the factors of 42, 7 and 6 would give me a 1, and I need that bigger one to be positive. So that's going to be v plus 7, because I know this is positive. V plus 7, V minus 6. So 7 times negative 6 is 42, and 7V plus a negative 6V would give me a positive 1V. So now I'm going to look for things that I can cancel or eliminate that factor out. That's going to be V minus 6, and I can factor vertically and I can factor horizontally. So V plus 7 factors diagonally, not horizontally, I'm sorry, diagonally or vertically. So V plus 7 cancels with V plus 7 in the upper left. And then I've got 20V cubed and 4V. 4V goes into 20V. 4 goes into 20 5 times. And V, if you take that 1, if there's a 1 exponent there and subtract a 2, or subtract a 3, you're going to get 2. There we go. So now on the top, I have left V minus 7 all over 5V squared. And I usually try to keep things in parentheses to know that they're a term. Does that make sense to you guys?
Yes.
Yeah.
Okay. I'm going to go ahead and do number 12 because it's kind of fun to see how it goes and how it simplifies all the way down. So I am going to do that one. You can't cancel anything at all, or you can't factor anything at all in the first rational expression. So you simply have 2n minus 3 over n plus 1. And then factoring 2n squared plus 5n plus 3, I'm going to kind of do my side work. I do slide and divide, but I think Miss Wynn does something else. And I don't want to confuse you and Garrett, so maybe I should do, and I don't want to confuse Anna either. Because I do the slide, and maybe I'll just do this twice for you guys. That's going to give me n squared plus 5n plus 6. So I'm looking for the two factors that multiply to give me 6 and add to give me 5. I slid up here, and now I'm going to divide down here. So that's going to give me 2n plus 3 n plus 1. I know that Miss Wynn does hers this way. And then this bottom one is a difference of 2 squares. Garrett, the way Miss Wynn does her factoring, she does it where she gets she does the AC method, and it turns into 4. Like instead of having a trinomial, she then gets it to a polynomial with 4 terms.
Mm-hmm.
So she would do it like this. She would go, what does AC, the AC method, comes to 6. And what are the factors that add to be 5? So she would do it like this: 2n squared plus 2n plus 3n plus 3. And then she would do grouping.
I did it the way you did it before.
Oh, you did? And you're good with that?
Mm-hmm.
Okay. You're still going to get 2n plus 3. And then n plus 1. But I just wanted to make sure I showed both ways of factoring, because obviously this is the math lab for both classes. But this is the other way to factor that same thing on the top. Okay? That's both methods. And Anna, I don't know, you may like this method better as well. So I don't know how. I've only shown this once in class, and that was way back when we were doing factoring. So
I usually just do slide and divide because I like remember how to do that one, but I like
great, and that's fine. It's just nice to know there are several ways if something gets tricky, because sometimes being able to group them is a little easier. So, but good if you've got slide and divide and that's working for you, praise the Lord. Okay, now that we've gotten everything factored, the next step is to look for those things that can cancel either horizontally or vertically. And we've got, oops, still had my eraser on. I'm not horizontally, I said it again. Vertically or diagonally. I'll get this right. Okay, so we have one of those. We have 2 of those, actually. We've got 2n minus 3 and a 3 minus 2n. So if we multiply by -1, and let me clarify something here. That's the only one that works with the -1. I want to explain something. With addition, so you have 2n. So let's just take a look at this. 2n plus 3 over 3 plus 2n. Well, we might think, oh, that must be one of those -1 things too, right? Because they're flipped. But the difference is this is addition, and the addition property is naturally commutative. So it wouldn't matter the order of these two. Does that make sense to you guys?
Yes.
Okay. So these just cancel. But this one and this one eliminate to be the -1. So your final answer, you have everything else is completely canceled out except for the -1 at the top. So that one kind of had some different nuances to it. So that's one of the reasons I wanted to walk through that one with you guys. Everything okay?
Yes.
Okay, cool.
Yep.
All right. I don't see anything particularly unusual about 13 at all.
Could you do 14?
I can do 14, but number 13 is pretty straightforward compared to the other ones that we're doing. So I will go ahead and break down number 14. I thought I was just going to whip through the odds, but 14 looks like a better one to tackle.
Yeah.
Mostly because of the delightful factoring that you have going on. This is going to be a fun slide and divide.
Yeah.
And I'm just sitting here trying to think. Okay, so I didn't. 63 times 6. I am, if with y'all's permission, I'm going to use this box over here to do my factoring for that top. Trinomial.
Okay.
So it's 378. So I've got c squared plus 13c minus 378. Now for me, I'm one of those kind of people that I like to just go ahead and I'm looking for factors. I won't do it. I know that y'all don't like that birthday cake method, do you?
No.
It's my favorite. Okay, so 189 and 2. And then let's see. I'm going to do on this, I'm going to do 9 and 21. Which gives me 3. So I'm looking for factors that, and I think that's it. I'm looking for factors that multiply together to give me that negative 378 that add to give me this 13. And if I do 3 times 3 times 3, which is 27, and then 7 times 2, that's 14. So 27 and 14. So c squared c plus 14. Nope. Because one of them has to be negative, and I need my bigger one to be positive because this is positive. C minus 14, and then C plus 27. Because 27 minus 14 is 13. So now I'm going to divide both sides by 6. And over here, you're going to reduce each of the fractions. This might have been one that would have been better for that grouping thing. C minus, and then you'll reduce this to 7/3. And that can't be reduced anymore. and you'll reduce that to 9/2. And so that then becomes 3c minus 7 and 2c plus 9. That was a factoring doozy.
Oh, that was only one of them.
Yes.
Yeah.
Yes. I know. I know. But did you all get all that written down before I erase it?
Yeah.
Yes.
Okay. And did you follow what I was doing? Did that all make sense to you guys?
Mm-hmm.
Yeah.
Okay. I know neither one of you would like to do it all by yourself, but I'm just want to know that it did at least make sense and that you could do it on your own.
Maybe.
Maybe.
Yeah.
That might have been one, Anna, that would have been a really good one for that a good candidate for the grouping one. It might have been a little easier because sometimes when you have to reduce the fractions, I know that that's y'all don't like fractions very much, so that might have been a little better maybe for that one. So maybe I'll try grouping for this second one.
Okay.
6c squared minus 17c plus 7. So the AC method, Anna, says, because I know Miss Wynn uses this pretty consistently in her class, so I know Garrett is familiar with it. But what that means is I'm multiplying the coefficient of the A term and the coefficient of the C term to give me 42. So then I'm going to factor that 42 to give me something that multiplies to give me 42. And then when I do the combination of them, it's going to give me 17. So I'm going to start with 21 and 2. And then that factors to 7 and 3. So let's see. We've got a positive 42. So that means actually both of my factors are going to be negative because I've got a positive, but my this middle term is negative. So what I'm going to do then is say 14, 7 and 2 and 3 add together to give me a negative 17. So all of these would be negative. So you would have 6c squared. And then you could put either your 14 here or your 3 here. Either one works. You could pick, but then that would be 3c. And then minus 14c. Those two, that's the two middle terms. Does that make sense,
Yes.
Anna? Okay.
Yeah.
Plus 42. All right. So now you're going to group things together. And I could take a 3c out of this first piece. And that's going to leave me 2c minus 1, right?
Yes.
And then over here on this second one, I can take out a negative 7. And that's going to leave me 2c minus 6. Right? Did I do that?
I think so.
Just making sure I pulled everything out right. Does that look right to you guys?
I think so, yeah.
Okay. 3c minus 7. Oh, no, I know what I did wrong. This should be a 7. I'm like, because I added, this is supposed to be a 7. I was like, something didn't look right to me. The AC method, I don't change that final constant term. So this would have been a 1. It's like something did not look right to me. Okay. I apologize for that. 2c minus 1. Because those two needed to factor. And then that gives you the 3c minus 7 as one of the factors. Factoring comes back with a vengeance, doesn't it?
Yes.
Okay. So the second one, the second part of this isn't as bad factoring. We've got 2c squared minus 9c plus 4. Y'all tell me which one. I'll do the AC method one more time. And so that gives me an 8. So I'm looking for two factors that multiply together to give me a positive 8, but when I add them, give me a negative 9. So that's going to be negative 8 and negative 1. So then that looks like 2c squared minus 8c minus c plus 4. I wrote it down right this time. Then you group, and I can factor out a 2c out of the first one. So it's going to give me c minus 4. Then I'm going to take a negative 1 out of this second one. And that's going to give me a c minus 4. So now I have at the top 2c minus 1 and then c minus 4 all over. And then I can factor out a 6 of the bottom. And that leaves me 2c plus 9. So there's quite a bit of factoring in that one, for sure.
Yes.
So now all my factoring is done. I'm going to see what I can cancel or, what would factor out ultimately. And remember, I can factor vertically or diagonally. So things on the first one, if I can cancel anything out, the 3c minus 7 cancels with the 3c minus 7. I've got a 2c plus 9 on the bottom of the second one, and vertically I've got a 2c plus 9 at the top. So those two cancel. Vertically on the bottom in the first rational expression, I have 2c minus 1. And diagonally across from it, I have 2c minus 1. So what do I have left on the top? Is c minus 4 all over 6. Now that was a problem. There was a lot to do with that one. A lot of moving parts, for sure. Did you guys get that one written down? I'm sorry, sweetheart.
Will there be one like that on a test or quiz?
I don't think so. I try to keep stuff like that for the homework.
Okay.
I honestly do, because I think those are good exercises for homework, but I try really hard to just test you on the process itself.
Okay.
I wouldn't do, if I had one that was a little harder to factor where you had to either use the AC method with the grouping factoring, or you did the slide and divide, I would make it the bottom more like this over here, the 12C plus 54, where you only had to factor something little. Does that make sense?
Yes.
All right. Now, same principle. Once you get your keep, flip, change done, it's just like multiplying, because obviously we're going to be changing these to multiplication problems. So you want to keep the first, change it to multiplication, and then flip the second to your reciprocal. So keep the first. These are sweet after that one, aren't they? And then flip that second fraction or rational expression to its reciprocal. And then use your exponent rules. And you could do some of that. I personally, she recommends multiplying all the way across. But if you guys want to, you could do some of that diagonal eliminating. Do you all like that, or do you like multiplying across? Which way would you rather see? Do y'all have a preference?
I usually just multiply across and then cancel out.
Okay. All right. Let's do that then. Okay. So 14 times 18 is 252. And then you add your exponents, 4 and 5. So that gives me a 9. And then 3 times 7 is 21. And then 1 plus 2 is 3. And let's see, does 21 go into 252? Have either one of y'all checked that? 252 divided by 21. Yes, it does. Evenly and everything. It goes in 12 times. And now we'll use our exponent rules to combine the variables. 9 minus 3 is a positive 6. So it stays on the top. So you have 12m to the 6th. Okay, on number 16, keep the first. Change it to a multiplication. Flip to the reciprocal. Factor the numerator. So you're looking for 2 factors that multiply to give you a negative 28, that when you combine them give you a negative 3. That's going to be the factors negative 7 and positive 4. So x minus 7, x plus 4, all over 6x. And over here, factors, you can factor the 2 out of the denominator, and that's going to leave you x minus 7. So now we can see that the x minus 7s cancel, and this 2 cancels with the 6. So your final answer, oh, actually, I could have canceled this too. That would have been less complicated, wouldn't it? So your final answer is x plus 4 all over 3 times 2, which is 6. X. Does that make sense?
Yes.
Okay. Have I lost anybody?
I'm good, but for number 17, would you flip it so it's 1 over 10a plus 70?
You're a genius. Yes, you would.
Okay.
Absolutely. Way to go. Good job. So it would look like 2a squared plus 14a, because you're going to keep the first, change it to multiplication, and do the reciprocal. And this is really understood to be this. So the reciprocal of that is, in fact, exactly what you said, Anna. So good job. And then factoring the numerator in the first expression, you can factor out a 2a. And over here, you can factor out a 10. So let's see, what can we can cancel the a plus 7, and then 2a becomes 1, and this would become 4a, because a minus a squared is a, and then you would be left with 1 over 4 times 10 is 40a. That's what you have on the bottom. How we doing? We good?
Yes.
All right. On number 18. So you keep the first. Change it to multiplication. Flip the second. Which that factors, this is the top over here. I'm hoping you guys are recognizing that. That's the difference of two squares. So, because one is a perfect square, so that's going to be factored to 1 plus h and 1 minus h. Are you all starting to see that pattern a little better? Yeah. And down here, I can factor a 2 out all the way across, so I don't have to do slide and divide or the AC method. Are y'all relieved?
Mm-hmm.
So that gives me h squared minus 5h minus 6. I'm sorry, I probably should have written that down here, because now I don't. I'm going to just go ahead and rewrite that. And then here, I can factor out a 2h minus 1. And then this factors, the bottom factors to two factors that multiply together that give me a -6. Then when you combine them, give you a -5. That means one has to be positive and one has to be negative, and the larger has to be negative. So that's going to be h minus 6 and h plus 1 times 6 over 2h minus 1. Okay. H plus 1 will cancel with 1 plus h, and because the addition property is commutative, it just cancels perfectly. I hope that makes sense. Does that make sense to you guys?
Mm-hmm.
And then the 1 minus h and h minus 1 cancel, but give me a -1. And then this 6 and 2 cancel to give me a 3. So I now have, for my final answer, which I'm going to write up here, hopefully that's not confusing, I've got this -1 times 3. So my top is -3, and my bottom is 2 times h minus 6. I'm going to leave y'all to try 19 by yourself, because basically it's not going to be that weird factoring, because up here you can factor, although that's going to be in the denominator when you do it, but you can factor that 4 out. So the factoring isn't really all that bad on that one. And I'm going to skip to do number 20 because you've got multiple operations going on. So I'd prefer to hit that one. Is that okay with you guys?
Yes.
Okay. So
I have a quick question for Sparks.
yes, love.
Is this the only paper we have due tomorrow? Because there was another packet that we got.
In my class, the other one was the actual notes and the example problems, and it looked like this. Is that what you're talking about?
Yeah.
I don't know what she's taking up, so you might want to clarify that with her. We did these in class, in my class yesterday.
Oh, okay.
I don't know. Anna, we didn't get to some of the bottom ones, though, did we?
No.
And so what I might do, Garrett, is go over like number 16 at the bottom, number 15 and 16 on that. Would you like me to do that, Anna?
Sure.
Okay.
I was just saying that because I actually have to leave right now. I just want to make sure that I miss a substantial part of my homework.
Okay. What I'll do is do number 20, and then I'll do the last 2 on the other page, because they would have probably been the hardest. I think you'll be good on the other 2. And you might want to just email her and find out what she's going to take up.
Okay.
Because I typically don't take up mine until the end anyway.
Is this being recorded?
Yes, sir. So
Okay,
I'll post the link, and you can just skip to the end. Okay. All right. For this one, Anna, you're going to want to keep the first. Change to multiplication, and just like the other one that you were so observant on, this is going to be 1 over 5x minus 1, because that's the reciprocal. This would have been like that. And then you're having it multiplied by one final term, but nothing about that changes. It just stays exactly the same.
Okay.
So now we're going to factor this first one, where you can factor out a 4 at the top. And on this, I would go ahead and cancel that out. But because there's so much going on all the way across, just to be on the safe side, I'd go ahead and multiply all the way across and then reduce, just because there's so many terms. Does that make sense?
Yes.
Okay, so you'd have 24x over 40x squared, which 8 goes into both 24 and 40, and 8 goes into 24 3 times, and it goes into 40 5 times. And then using your exponent rules, we've got 1 minus 2, which is going to give me an x on the bottom. So my final answer is 3 over 5x.
Okay.
And then I'm going to go back over here. Did you get these yesterday in class?
Yes, I did them on my own.
Oh, you did?
Yes.
Would you like to see them so that you know that you got them right? Or
I actually have to go right now because
okay.
I leave in a few minutes, but I'll probably watch it if you like when it's recorded. Okay.
All right. Is there anything else that you would like for me to cover from yesterday's classwork or today's homework that you didn't see?
No, I'm okay. Thank you, though.
Okay. Great.
Thank you.
Well, have a lovely afternoon.
You too.
All right. Bye-bye.
Bye.
Factor out a 2a squared. Let me start over. I'm going to do I was going to factor and then flip, but I don't want to do that. Rewrite the first. Change to multiplication and flip the second. Now factor out a 2a squared off of the top. And now I'm looking for two factors that multiply together to give me a negative 12, that when I combine them, give me a negative 4. And that means the larger factor is going to have to be the negative. So a minus 6, a plus 2. Looking for factors that multiply to give me a positive 15. When I combine them, give me a negative 8. So that's going to be a negative 5 and a negative 3. And then on the bottom, I can factor out an 8a squared. And that's going to give me 3 minus a. So a minus 6 cancels with a minus 6. And this cancels, a 3 minus a cancels with a minus 3 to give me a negative 1. Two a squared cancels with 8a squared to leave a 4. So on the bottom, or on the top, I have negative 1 times a minus 5 all over 4 times a plus 2, which can be written like this. I'm happy if you leave it here, but this can be written like this. Either way is perfectly acceptable. And then number 16, rewrite the first, change to multiplication, flip this to its reciprocal, and the last one stays the same because it's just being multiplied. Nothing can be factored out of this first one. And nothing can be factored out of this second one. But this final one, the top, I'm hoping you guys are starting to recognize the difference of two squares. 16k squared and 1 are both squares, and that's the difference of two squares. So that factors to 4k plus 1 and 4k minus 1, all over k plus 3. You'll note that k plus 3 factors diagonally with k plus 3, and 4k plus 1 factors out the 4k plus 1 diagonally. So on the top, we have 4k minus 1 left. And on the bottom, we have k. So that's your final answer. So that concludes Math Lab today. Hope y'all have a great afternoon.